In this lecture, I'll be talking about taints and tolerations. In the previous lectures, I explained to you the following concepts: node affinity, which is similar to the node selector, interpod affinity and anti-affinity, and the next concept, tolerations, is the opposite of node affinity. Tolerations allow a node to repel a set of pods. So instead of using node affinity to make sure that pods run on specific nodes, this is the opposite. We can say that pods cannot run on these nodes. Taints mark a node, and tolerations are applied to pods to influence the scheduling of the pods. I'm going to talk about taint and tolerations. Taints are applied to a node and tolerations are applied to a pod. One use case for taints is to make sure that when you create a new pod, they are not scheduled on a master. When you run a cluster that has more than one node, the master has a taint. And the taint that the master has is called the node role Kubernetes IO/master, and the type is noSchedule. Because this master has a specific taint, you can only schedule on a master when you have a toleration applied to your pod. And by default, you don't apply any tolerations. So by default, you will not schedule on the master, you will schedule your pods on the other nodes. If you still want to schedule on the master, you can add a toleration, or you can remove this taint as well. To add a new taint to a node, you can use kubectl taint. For example, kubectl taint nodes node 1 key equals value, and then colon noSchedule will add a taint to a node. You can specify key equals value. The key and the value you can specify yourself. This taint that is applied to the master doesn't have a value, it just has a key, the node role Kubernetes IO master. The taints applied by Kubernetes don't have a value. So at this point, if you apply this taint, no pods will be scheduled on this node 1. This will make sure that no pods will be scheduled on node 1 as long as they don't have a matching toleration. The toleration needs to match this key equals value. The following toleration would allow a new pod to be scheduled on the tainted node 1. This toleration you add to the pod specification. It has the key, the operator equal, and the value, and the effect noSchedule. So this matches the previous taint that I created on node 1. So if you would create a pod or a deployment that uses this pod specification, then this pod could be scheduled on node 1. You can use the following operators: equal, providing a key and a value, as in the example above, or exists, only providing a key, checking only whether a key exists. Just like affinity, taints can also be a preference or soft rather than a requirement. noSchedule is a hard requirement that a pod will not be scheduled unless there is a matching toleration. Prefer noSchedule. Kubernetes will try and avoid placing a pod that doesn't have a matching toleration, but it's not a hard requirement. So it's exactly the same as with affinity. Just the naming is a bit different. If the taint is applied while there are already running pods, these will not be evicted unless the following taint type is used. noExecute will evict pods with non-matching tolerations. So if you apply a taint using the type noSchedule, then current running pods will not be evicted. If you use noExecute, then pods that are already running will be evicted. When using noExecute, you can specify within your toleration how long the pod can run on a tainted node before being evicted. Let's say you have a pod with the following toleration. It's the same as the previous toleration, but here the effect is noExecute and the toleration seconds is 3600. So this specification will make sure that if a taint is applied to a node where the key is key and the value is value, then this pod will run for 3600 seconds more and will then be evicted. If you don't specify toleration seconds, the toleration will match and the pod will keep running on the node. So if you don't specify this toleration seconds, then it always matches and the pod will just keep on running, just like a normal matching rule. In this example, the toleration will only match for 1 hour, 3600 seconds. After that, the pod will be evicted from the node. So it's a bit difficult to understand maybe. If you specify the toleration seconds, then the pod will be evicted after this time if the toleration matches. If you don't specify toleration seconds and it matches, then it will always be there. It will not be evicted after a certain amount of time. And of course, if it doesn't match, then it will be evicted immediately. Some example use cases are the existing node taints for the master node. As I explained, you don't want to be scaling anything on the master nodes. Those have their own function. Taint nodes that are dedicated for a team or a user. Let's say a team or a user has a specific node that only he or she can use, then you can also use taints. If you have a few nodes with specific hardware, for example GPUs, you can taint them to avoid running non-specific applications on those nodes. Depends what the easiest is for your use case. You can use affinity or you can use the opposite, which is taints. An alpha, but soon to be beta feature is to taint nodes by condition. I'm doing this lecture when version 1.11 is already out and this feature didn't make it, so it's still in alpha now. But in one of the next versions, it will be in beta. So the taint nodes by condition will automatically taint nodes that have node problems, allowing you to add tolerations to time the eviction of pods from nodes. So this is a very specific feature. A node problem example can be that there is no disk space left anymore. So then this node will be tainted and then you can time the eviction of the pod from the node. You can enable alpha features by passing the -- feature gates to the Kubernetes controller manager, or if you are using kops, you can use kops edit to add the following lines. So this feature can be enabled by taint nodes by condition true, but I would recommend you to maybe just wait until this feature is stable and then you can just use this feature. In the next slide, I will show you a few taints that can be possibly added when you enable this feature, and then you can create tolerations for those. So here is an example of toleration that could be used. Toleration, if this node alpha Kubernetes IO/unreachable key exists, then the effect will be no execute, so it will evict all the pods on this node, but you can say I want only to be evicted after 6,000 seconds. Because maybe if you're gonna reschedule a pod, it will take a lot of time, so sometimes it's better to wait some more minutes to be evicted. If it is reachable again, then no work needs to be done. You have the node Kubernetes.io/not ready, a taint that can be applied when the node is not ready. Unreachable, when the node is unreachable from the node controller. Out of disk, the node becomes out of disk. Memory pressure, the node has memory pressure. Disk pressure, the node has disk pressure. Network unavailable, the node's network is unavailable. Currently this is only the host network. Unscalable, the node is unscalable. So these are the taints that are applied on those nodes, and then you control the eviction time by using these tolerations. In the next demo, I will show you how these taints and tolerations work in practice.